Hi and welcome. So this time around I've got the last in my series of parts for this one customer that you've been seeing up till now. You know, the working with Delrin parts and some interesting aluminum parts. I made 5 more parts that were unique. Well, actually one of them I'd made others of before. You saw this one being made. He wanted one more of those. This one out of Delrin, the other one's here out of aluminum with some pockets and stuff. Nothing particularly complicated, so I didn't show those. But this last part is kind of interesting because it needs to be made out of 1/4 inch stock, this little scrap piece here. This is just some tooling plate, precision plate. And what it needs to be is, you can see it starts with 1/4 inch, but most of it's 1/8 inch wide with a slot in it. And the question comes, how do you hold and machine a slot in something that's only an 1/8 inch thick? Now, there's a bunch of different approaches, but the one I want to take today is using Superglue. And I've done it before in videos long ago. It worked out really well. So what I'm going to do is I'm going to pop some Superglue under this part. I've deburred it so that there won't be any chance for burrs to hold up one of the edges. I'm going to put some super glue under this guy, put a plate across this, put this in my hydraulic press, and squeeze down, and that should lock the parts together. It's worked really well in the past. You could use your vise if you don't have a hydraulic press. Not everyone does. That also works well. Super glue is surprisingly strong if you get a good prepped surface. I'll also clean it with acetone before I put the super glue down on it. Yeah, so you can get a really strong bond with super glue, but the nice part is it degrades at something like 175 Fahrenheit or 150 Fahrenheit, somewhere around there. So you don't have to heat these parts too much with a little brazing torch, and you can pop them apart and then clean the super glue off. So it's a really handy method of holding parts that are thin, because you can put it to a much more solid piece and have that give you stability and strength. So I'm going to prep this piece real quick. Just take some acetone here. I don't spray it everywhere. Clean these parts up. Clean the bottom of this guy up. And we'll apply some super glue, and I'll use a press plate above it so that I don't damage this one. I don't have to get this any particular orientation. This is much larger, as you can see. It needs to be 0.65 inches. This is over an inch. So what I'm going to do is I'm going to relieve material across it and then cut it to size maybe after. This is a little bit over the length I need as well. Thought I'd give you a quick look here over the hydraulic press. So there's the pressure plates, and you can see the parts there being squeezed. And I spread the super glue evenly before, but it tends to spread out nicely when you put 10, 15,000 pounds of pressure or more on it. So I just leave it sit there for a few minutes, and when I'm done, it's pretty amazing how well adhered it will be. All right, the first step is we're just going to try and dimension this stock, so we're going to take some material off. I'm going to set my zero where the cutter is just slightly going into the base plate here. All right, well, since we're still rolling, I walked the end mill around the outside perimeter here, got my final length to what I want it to be. My width is much larger than I need it, but I am going to leave that. So the next part is I want to make this, this material is actually slightly thicker than 0.25 inches. We're going to take off about 8 thousandths off the top and make it 0.25, it's 0.258. It's consistent 0.258, so that's probably an advantage. They probably make it a little bit oversized so you can get the final dimension that you're interested in. So I'm just going to run the end mill over the top real quick, get the final dimension on the size, thickness-wise. Next up, I need to start removing material to get this down to 1/8 inch thick. So I got to go down 125 thousandths. So I am just this side by about 20 thousandths of my final thickness over here horizontally. And so now I'm going to go on the Z-axis. I'm going to bring this up about 25 thousandths, and I'm just going to go straight across. I'm going to make my line of demarcation. So I've got a few passes to go, I'll bring you back. All right, so I changed my mind and I fully dimensioned the part on an outside dimension. So now it's 0.650 by 4 inches with 1/2 inch right here. And now I need to do the 4mm slot and then drill a hole right through the end. And that'll be it. And then I can heat it up with a torch and pop this guy off. Alrighty, next up, we're gonna do the slot. And he's got it spec'd at 0.156, but I talked to him and he's interested actually in 4mm exactly, which works 0.157 is close to that value, not 0.156, but he's plus or minus 5 thousandths anyways. So we have to start in. So I set my 0 with the end of with the center of the end mill was right on here. So then I had to offset it half of 4mm, which was half of 0.157, which put the far edge at 0. Then I went in 0.115. I'm actually going to go in 0.120 so that I can finish the last 5 thousandths on each side more carefully. So I'm going to go between 0.120 and then he wants to go another 2.085. So what I had to do is take 2.085, add it to 0.115, and then subtract the diameter of the end mill because I was referencing off of this side of the end mill, and that comes out to 2.042 is my final dimension, but I'm going to go between 0.120 and 2.035. All right, so slot is in. Next up, we got to drill a hole through this side and drill a hole through the top to meet it. That should be interesting. Oh, drill and tap, 832. We'll start with the spotting drill and move straight away to the number 8. Okay, all the way through. Now we have to come through this side, and I'm a little bit uncertain as how to do this. So I've made this, the sides of this piece are all rough, and if I'd been smart, I would have run a quick pass around all the sides and gotten it square before I started. But now I can't really do that, so I think I have to take this piece out to try and drill and tap that. I'm afraid this is acting a bit too much as a heat sink for this tiny torch, so I'm going to go pop it on the stove, the natural gas stove in the house, and it should just pop right off. Alright, so I popped this on the kitchen stove for about, I guess went this way, for about 3 minutes, and it heated up enough that it just popped right off. Wasn't a problem. I roughed the bottom of this up so that it would make better contact, because the first time it popped off, I've had that happen before. I just left the material as is, and there's probably just too much of a smooth oxide layer. So once I roughed it up, it worked great. I was doing some pretty heavy cuts for a while. So next up, we got to drill in this end, and that should be a trick. We're gonna have to support the part. All right, so I got a part mounted in a couple support blocks, And we just need to drill through because this is going to be tapped all the way through. And that's it. Take it over, tap it, and I'll be done. Alrighty, here's the last part done. It worked out really good. I was just cleaning it up with some Scotch-Brite, and I use alcohol as a lubricant to keep it from loading up so much. It came off really easy on the stove. Drilled and tapped the top. There's a set screw in there right now. Meets in the hole, pretty nice. Deburred the hole. And so this part's done. I was really surprised how well it turned out. The super glue technique learned from Tom Lipton, and it does work. You just have to make sure you get good adhesion. Every once in a while you don't, like you saw earlier on. The other parts here, I clean them up with a little bit of Scotch-Brite as well, and some alcohol, and we're ready to ship. I hope you find it interesting. Thanks for watching. Hope to see you next time.